Hey, it's Mr. Light. So we've done some stuff with inclines, free body diagrams, tilting the thing, all of that. We've also done some stuff with friction and the coefficient of friction. Now let's see if we can't get them to work together. Okay, so today we're going to be looking at friction again, but we're going to be using something a little bit different to pull the brick. If you remember last time, we pulled the brick with the force probe and at a constant speed. So thus we said that whatever we measured on the force probe was the force of friction because those two forces canceled out due to the fact that it's a constant speed. Today we're not going to use a force probe, we're actually going to use gravity. So the idea behind the lab today is we are going to put this on an incline plane. We're going to lift the incline plane until the brick moves at a constant rate. You see that? Now the brick's moving at a constant rate. So what we're going to do is we're actually going to measure the height of this incline. So we're going to take a meter stick, take our 1 meter mark here, and we're going to measure that height so that we can get the angle of the incline. We can then change all kinds of variables. We could change the type of surface that we're going on. We could change the surface area that we're going on. But you know what? Those things, we already kind of know what's going to happen. We know that the surface area affects the coefficient of friction, which will probably affect how sticky the surfaces are and whether or not it's going to go down at that angle. We also know that the surface area doesn't make a difference, so that's not a big deal. What I'm interested in, though, is mass. How does the mass affect this thing on the incline plane? So what we're going to do is we're going to change the mass and see how that affects the angle. So if you're not in class today, you're not going to be able to make some of these observations. So I'm going to kind of give you an example of how this thing works so that you can kind of come up with what are these observations that are important. One of the things that's kind of interesting is when you actually start doing this. If I lift this thing up to get it moving, it starts moving, but then did you notice what I have to do in order to keep it at a constant rate? Initially, in order to get the brick started to move, I had to lift the incline higher. And once it started to move, then I dropped it down to get it to go at a constant rate. That's an observation you're probably not going to have unless you're in class doing this. So those of you at home, I want you to think about why that is. Why is it that I have to go to a higher angle in order to get it started moving, and then I go to a lower or shallower angle in order to keep it moving? All right, let's get into this activity. What we're going to do is we're going to actually change the mass of the brick. So I'm going to go with 1 brick right here, just to give you an idea of what that looks like. So 1 brick right here. There's the angle that I'm looking at. Now, if you have your TV or your computer, you can kind of look and actually see what this angle is. Maybe you can put a protractor up to your screen. You could probably measure that angle. In class, we're going to use a ruler or a meter stick in order to calculate this out. But do you see how this is? At this point, let's say it's right here at grade Scott. It's right here in the middle of my shirt. Okay? So let's see if it's different or how different it is when we put 2 bricks. Do you have a prediction on this? Do you think it's going to take more gravity to pull it down or less gravity to pull it down? Think about that for just a second, and then I'll do it. All right, so I got my 2 bricks. Here we go. I'm going to lift this up. It's the same brick on the bottom, so we have the same surface we did before. We're going to get this moving. She's moving at a constant rate. Now I have doubled the mass here. I have 2 bricks, and they're about the same size, so I doubled the mass. If you look here, this angle is still right at my shirt. The angle didn't change appreciably. And if you're in class today, you're going to take some data and you're going to figure that out, that every time you took that angle, every time you added mass to this, the angle barely changed at all, if at all. So your job now is to show me mathematically why that's possible. How is it that the mass doesn't make a difference? Can you use our equations in our free body diagrams for inclined planes and friction in order to show me mathematically how that happens? This is going to be very similar to those problems on the test that don't have any numbers. Can you keep the variables, crossing out variables, and derive an equation for the angle of the incline based on all of these factors, and mass shouldn't be in there? See if you can't do that. That's your goal for today. When you're finished with that, there are some questions at the bottom about inclined planes and friction. So go ahead, work through those, and I will see you next time.